David leads work in the Azure Innovation Office on machine learning. This means he spends most of his time helping humans to convince machines how to be smarter. Oh, he is only moderately successful at all of this.
Someone just texted me and asked if I was going to sing. I am, because I want there to be more than 0 attendees, I will not be singing.
Oh, man. You could. So what did you play back in the day?
Guitar, piano, trumpet, and I actually did sing opera. But these were all purely for private pleasure.
Okay. This is the last
nowhere
one.
near as successful as getting all of South America to back you on Spotify.
All right, here we go. Last part, and then we're gonna bring it home, and I'm gonna give you the spotlight. Previously, he led product management for Kubernetes on behalf of Google. He launched Google Kubernetes engine and co-founded the widely famous Kubeflow project that you've all heard of. He has worked at Microsoft, Amazon, and Chef. By the way, he co-founded 3 different startups when not spending too much time in the service of electrons. He can be found on a mountain, traveling the world via restaurants or participating in kid activities such as football, soccer, what other kind of, or just plain tag. There's a lot more to remember when he was that age, and we're gonna hand it over to you, David.
Hey everyone. Boy, if I had known, I would have written my bio in iambic pentameter or something so that it was a little bit easier to sing. I just had no idea.
It's all right. Even if it was easy to sing, I still would botch it. So.
All right. Well, look, in the spirit of context for everyone, I was in the MLOps Slack, which I assume you're all in, or many of you are in. Highly recommend you join. It is one of the densest areas for people to talk about machine learning, the process of machine learning, the process of MLOps, how to bring your things to production. And it's just incredibly engaging. And so I was in there in that chat, and Demetrius, we can link to that thread, right? Or excuse me, that particular sub channel.
Yeah.
Highly recommend. Spend an afternoon reading through that. The amount of wisdom dispensed in there is enormous. And one of the problems that kept coming up was, boy, all our data scientists do work in notebooks or these other exploratory environments. It could be a notebook, could be Python, could be any language you choose, but there is a lot of exploration. How do we, understand whether or not something is converging? How do we engineer this feature, this data properly? How do we sample it? All that kind of good stuff. The problem is that after that exploration, the question is, how do you then move it to production? And there are lots of philosophies around this. Some people say, well, we should rip the thing out and never move it to production because it's just not suitable. That's a defensible step. one of the problems is that ends up being a big gap. Teams often don't have secondary teams who are ready to do that kind of translation. Even if they do have secondary teams, that means if you wanted to go back and change something about the model, change about the way something was engineered, or add a whatever convolution layer or something like that, you then have to go back to that notebook, and that means you repeat the process of doing that translation, which causes drift. And there's also the loss of intent. When a data scientist or a developer is sitting there building their model, they're like, okay, I'm going to do this here, and I know it sounds silly, but I'm going to multiply everything times, whatever, negative 0.99. And then someone downstream looks at that and they're like, well, this is a silly step. I'm not going to do it. And then, the intent is lost. And then when the thing gets out to production, they don't know what the hell went wrong. So that's a long way of saying I'm not a fan of that. That is a very standard process, by the way, for people to do. They take this experimental thing and translate it. The question is the other option, which is take this thing raw and move it to production. There's really not any formal systems for that, or platforms or things that do that today. There are lots of hosted cloud notebooks where you go off and operate on the thing. But those are not ideal because they often execute what I call monolithically. So basically you take this entire thing, throw the entire thing in a container or on a single VM or on a whatever, and then just run it. But that's not ideal either. So that's a long way of saying, we had this conversation in the chat in the chat room. We started talking, and I said, look, I'm working on this project. Would you like to see a demo? It is very, very proof of concept, but directionally, we're starting to get to something, I don't know, kind of interesting here. And so I wanted to show you all. The code is out there, but the binaries are out there, but the code is not. And it's just me doing the work right now. We're working on figuring out exactly how to open source it. It will be open sourced very shortly, but we're just getting there. So that's the context to talk to you about this new project called the SAME project. SAME stands for Self-Assembling Machine Learning Environment. And it's a great, it's definitely a retronym, because what I wanted to do was have this thing execute the same on your laptop, in the cloud, on Cloud B, things like that. So just had to figure out a way to spell it. All right. So let me get to the exploration, and I really do. So I can't see chats. Oh, here, Demetrius, just weigh in if there's a chat or something, and I'll go forward, or I'll let people know.
For sure. I just want to point out something that I have not seen before. How'd you get the subtitles on?
It would be a remiss of me if I didn't mention that this is my employer, Microsoft. Comes standard with, in my opinion, some of the best subtitling I've ever seen.
Yeah,
it's really good. So I hope you don't mind the distraction. And for those who haven't seen it, I'm a big believer in accessibility and things like that. So I always try and give these talks with subtitles and so on.
That's awesome. And can we get that? How do we get that?
So this is just in PowerPoint. It's an option you check to leave it on when you're in display mode. I don't know. I'd be very surprised if there wasn't another solution for this. I don't know if that means use Teams or something like that. I really have no idea. But Google Slides as a PowerPoint export. Go export your stuff to PowerPoint. Your slides to PowerPoint and present, and that'll work.
Awesome. Well, I'll keep you updated on the chat in case anything comes up too.
So this is a kind of general thing. Lots of you are already going to know most of this stuff. But the reality is that far too many platforms ignore this very statement, which is Jupyter Notebooks are the center of gravity. And a lot of people outside of data science don't really understand that a Jupyter Notebook is really many things, right? It's a file format, an IPyNB file. It's a IDE. It's a kernel that executes. It's a system of tools that understands it. All of those things together have really just transformed the way that people do data science. And Using these are public numbers. There are papers about all of this stuff out there. The growth of Jupyter Notebooks on GitHub, right? This is setting aside all those private ones that are hidden off there, is enormous. Up, more than 600% since 2017. And just, the torrid pace growth. Those are unique notebooks, not forked, not anything. We can tell what's forked in the public GitHub data. You also see that, up by unique users. Over 700,000 unique users have uploaded to GitHub. And again, I'm just referencing GitHub. Again, full disclosure, it is a Microsoft property, but I'm only referencing it because they publish all their data. And so it's very easy for us to mention that. And then if you go and look at LinkedIn's public data, you're able to find 2.1 million people who have data science as part of their name. So again, are these numbers inaccurate in myriad ways? Absolutely. But directionally, I think you can see that the way things are going. So this is where data science is happening. It's happening in the Jupyter Notebook. However, notebooks by themselves are not particularly well suited to production. And it's not because of the code being written in them. Yes, lots of the code is fairly gross. I've written much of that myself. But that's not the core of the issue. The core of the issue is, first, we need to recognize that these notebooks do need to be run in some production environment. Now, again, I'm caveating this by saying, look, if you're just building a model for yourself or some small team, sure, absolutely, train on your local laptop, you're fine. But most folks who have particularly security concerns, need access to production data that might include PII, personally identifiable information, might need to scale. My laptop here, even though it's a brand new laptop, only has 1 GPU in it. It cost me whatever, $100 to spin up an 8 GPU machine in the cloud for a week. So there's lots of more accessibility that you can do in this cloud environment that I just am not going to be able to get to on my local machine. And so first, recognizing that notebooks do move is an incredibly important point. But most systems are not ready to accept raw notebooks, right? What they want is a Python file or a container or a compiled binary or something like that. And that often requires significant rewriting and very, very often will miss many local settings. So all of you out there, as I have done, who do, pip install, requests in line in your notebook, that is like a super anti-pattern. Because when you go and you make that translation into any other kind of production interface, that will not be included in your requirements.txt and therefore won't run in production. And you're going to run it and it'll take 10 minutes to spin up. And then you'll see like failed, request not recognized as a module. It's so annoying and it happens all the time. And then even if you did do all that work to do that translation properly, you really are still missing out on a lot of opportunities to do production-like things, right? So for example, let's go back to my example here. Let's say I have 100 gigabytes of data that I want to process. And step one of it is, going through all that data and feature engineering it, pulling out the features that I care about, putting it into a single data frame and executing. That is something that's effectively embarrassingly parallel, right? You could execute it trivially very fast on a very large compute cluster, but most data scientists don't know shouldn't care about how to, fan out, execute, reassemble all that data and things like that. But workflow systems are very good at that. So even if you do that translation, oftentimes it's very easy to miss out on a lot of the opportunity that you get by moving to the cloud, accelerate things, make it observability better and so on. Okay, so what is SAME? What is self-assembling machine learning environments? The idea is we help notebook developers move from the environment they know and love and build a reliable workflow right there in the notebook, yet enable that to now take advantage of these cloud patterns and parameterizable and things like that. I am trying incredibly hard not to reinvent many of the good tools that are out there already, right? DIL for serialization, Dask for fan in, fan out, and things like that. All sorts of various solutions out there are already out there. And I'm trying to embed those in a way that it doesn't require a data scientist to understand them. And we just basically build an abstraction layer on top of that. So, this is a classic example of me just building on the shoulders of giants. Our goal is, to go down this vision, right? One, to make notebooks portable, make environment capture much, much easier, enable platform portability. You're going to see in this demo, me demoing just against one platform, but I want to support every platform. The only reason it's just one is because I'm a single human being and I'm kind of coding everything myself right now in the proof of concept phase. Two, we think we can make people much better inside of notebooks by removing boilerplate code, by simplifying things, by kind of auto-generating stuff that they have to do today, as well as supporting best practices. And then third, as I mentioned, really improve that execution workflow. So one, make it declarative. If something is already installed, great, reuse it. If something is not installed, do the installation. So again, you don't have to think about that. And then, really support things like continuous development. So as you go through GitHub, you check in your code and, push it out to your deployment pattern of choice. It'll just continually run, or as soon as you do a tag. And this is totally compatible with managed services. So if you use Azure Machine Learning or SageMaker or Google Cloud or hosted Databricks or whatever it might be, we want to be compatible with those. Okay, so big vision, lots of distance to get there, but that's what we're doing. When we think about this, we really think about impacting three different key people, right? One, users, data scientists. We want to make it easier for you to just write notebooks. There's way too much boilerplate. There's way too much like figuring out if this Python version was right or this was correct over here. Like, can we do things right there in the notebook? Second, if you're a GitOps, MLOps engineer, any person who's responsible for testing and deploying this thing, enable that transfer, more easily, less rewriting, closer to the original context, closer to everything, and capturing the intent of the authors. And then finally, for those SREs, those site reliability engineers who have to watch this pipeline in production, let's make sure that this is now operating in a much more efficient way, where things can be built up, torn down, declaratively, saving money, improving security, performance, all that good stuff. In the landscape of machine learning, just to lay it out over here you have how to write the things, right? Whether or not it's Jupyter or PyCharm or VS Code or Eclipse or, I don't care, notebook.exe, right? You keep doing that. We're not going to change any of that. We're going to rely on those things. On the execution side, there's all these great platforms out there, Airflow and Azure Machine Learning and SageMaker and Google Cloud and Kubeflow and blah, 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 blah. Great. We're not touching any of that either. What we are is really that inner space. We're going to give you an SDK and a CLI and a bunch of adapters that move from that authoring environment on one side over to the place you execute, and do it in a really open source and community-driven way. Okay, so one of the core things here is what you see here, right? I've given this slide many times, but I just kind of want to touch on it because this is one of the biggest essences that we run into here. Lots of people obviously focus on just building a model. If you're a data scientist, you've probably seen that it's actually many of these things, right? Ingestion and transformation and model validation and then rolling out and logging and all that kind of stuff. That's what it takes to actually get something in production. Unfortunately, today, everything sits inside a single notebook, often, right? Unless you do some serious rewriting. And if you do serious rewriting, then oftentimes all that work that you did originally might get lost or things like that. Worse, the requirements for each one of these things is often very different. So for example, in your data validation step, maybe you need very low power machines with lots of RAM. In your building step, maybe you need, a ton of GPUs, but, very low RAM. And in the rollout phase, maybe you could do that, serverlessly. You don't need anything. Everything is, immutable. If everything is executing inside a single monolithic notebook, you have to optimize your resources for every step. So you need something with a lot of RAM and GPUs and serverlessly, declaratively, which is, obviously very challenging to do. Our goal here is let's let you break this up in intelligent ways and reuse just the resources you require. So like I said, the idea is you have your beautiful, great running notebook over here. You have your environments over here, dev, test, staging, different compute environments, different hosting platforms, whatever it might be. And the question is, in between, how do you convert this thing into a reliable workflow application? Our dream is to do it via this. You use a simple manifest file, and I'll show you what this looks like in detail, but it's really not much more than what you see here. And you use a CLI, and we will do this conversion into these things. And again, I'm not writing most of the converters and things here. I'm actually reusing the stuff that's already out there and just wrapping it. But again, we'll go whatever direction the community sees. So before I go any further, any questions?
I don't see anything yet, but maybe people want to jump in now.
Okay.
It looks like a quiet bunch. I'm sure things will come up as you start typing away.
Yep, no worries. Okay. Just seeing if anyone else texted. Okay, so I'm gonna walk through this video. And please dive in and ask questions along the way. Again, I cannot stress enough, it is very proof of concept, but I think you'll see the direction we're going. So over here, you have your standard notebook. The notebook is just as hideous as you can possibly be. We have hard-coded URLs. We have imports all over the place. We're defining functions in various locations. As we continue through here, you can see, graphs and images, tables. There's a picture of the Faroe Islands. You got a lot of stuff going on, right? And, we all see notebooks like this all over the place. It's kind of the state of the world. And, one of the things that we ask these data scientists to go and do is now rewrite this entire thing in a new way, which, like I said, I think is really, in a lot of ways, an anti-pattern. Should we help notebook authors do things in a more production-ready way? Absolutely. But to ask them to throw away all this stuff, I think really loses and creates this big gap that ultimately will hurt us over time. So in addition to the notebook demonstration here, we also have a text file that I'll fill in just a second. And then we have a CLI down here. So the first thing that I'm going to do is I'm going to go over here and I'm going to write a same file. The same file is really quite straightforward. It's just about 11 lines right here, and this is more than enough to go and execute this thing. Inside it, you have some pretty straightforward things. You have a metadata section that has a unique name and version associated. You have a pipeline section which points back at that notebook that I have running over there. And then you have a run section. And this is one of the most important things, because what you want to do as part of your production pipeline is capture all the parameters that you need in order to execute this run, because that's something you can check into code and execute as you go forward. So that's it. That's all I had to write. And, I had to only write that once. Now, again, like I said, I can check in the code and it'll just pick it up. From that, I'm going to go and execute same. Now, in this case, it says same program run. And I give it an experiment name. This is a little bit out of date. We don't even require this anymore. I'm actually able to pick up the experiment name from up here and the run name from right here, so we don't even need it. But it automatically looks at that same file. And then when it goes through, and that's it. Now, behind the scenes, I have already set up Kubeflow. Same enables us to set that up automatically in a single line command. Or you could connect to Azure Machine Learning, which I also
yeah.
support right now, and we plan on supporting many more. Again, it's just human beings contributing that will help. But you can see here that was it. It took that notebook and it automatically converted it into a format that was compatible with Kubeflow or Azure Machine Learning. In this case, I'm just doing Kubeflow because Kubeflow runs locally on my laptop and in the cloud, just to kind of show you what's going on here. And then what I'm going to do is I'm going to pop over to my what do you call it here? My same pipeline, and look at that Kubeflow deployment. And you can see that here. It's up and running. When I hit refresh, I can see this automatically executed here. And behind the scenes, what I did was I translated that into a very simple execution graph. So this execution graph, I injected this first step here, which gathers all the run information. This is something that most workflow engines require because I don't know run information until I start the run, right? I don't know what date and time it started. I don't know the UUID, all that good stuff. So I needed to inject this as part of my run on Kubeflow. And then I took the entire notebook and I put it inside this main step here. And I did all the conversion behind the scenes in order to support that and took care of all the imports, all the packages that you had in line. I gathered them, made sure that I knew what was going on. And then I ran through and executed it using the parameters that you see here. And momentarily it'll run through and finish. And you can see that here with all those ugly print statements, and here's me printing out variables and so on and so forth. Here's a version, so on and so forth. So without doing anything, a data scientist was able to take that notebook and just run it in the cloud, in this case on a Kubeflow. Now, you don't see some of the things, tables and graphs and things like that. We can get to lots more visualization if we want. Lots of people don't want that, but you didn't see me having to strip that manually out of the notebook. We just kind of like swallowed the output and then went forward. Were you going to say something? Okay. No worries. So, and in addition to that, remember I was defining functions all over the place and doing imports? I took care of that too. We're able to like grab the context using Python and still, create them and maintain them over time. Okay, so going forward from there, let's say one of the things I talked about earlier was I want to break these things up. We don't just want to execute these things against single environments. We'd really like to execute them against environments that make sense. But if you start to do that, you're asking data scientists to really pick up a lot of information. I have to understand how to do callbacks, context passing, all that kind of stuff. What if we boilerplated all of that? So what I did was I wrote a very simple tag recognition system. In here, in Jupyter Notebooks, they have a standard thing called tags. I could just type that, and here I have to type same underscore step underscore 1 and same underscore step underscore 2, and you can see those there. And what happens there is everything that was in between each of those tags is grouped together and has their own imports and packages included. And as a data scientist, I didn't have to think about any of that. It just went forward and ran. And then when I go back to my CLI, I didn't make any changes to the same file, and I type same program run and say, oh, you know what? Now it's the second run, so I'm going to instead do it with 2 steps here instead of 1. We go back, we re-execute, and when I go up to the cloud, you can see there's my execution step going. And this time, instead of a single step, now I automatically break this down into 3 steps, each one of which is executed serially and passes the context between them automatically. Now, again, this is pretty basic stuff, right? I'm not doing any complex graphs here and dependency trees and things like that. But again, that's not hard to do. It's just I'm one human being working on it. So it's going to take a little bit of time before we get to something more sophisticated. But all those function definitions, all the variable awareness, all that kind of stuff, piece of cake. It just works. And you can see here as we went through, it executed, and I'm able to now execute a completely separate a step with all the kind of conversion and environment capture. Now, one of the things that you do a lot of, one more thing that I'll touch on here, just as the proof of concept as we're going through, if you're like me, you love printf statements all over the place because it lets you watch as variables progress. That's something that's really easy to lose when you move to the cloud, either because printf statements get swallowed or logging is happening at some very, very distant place. With this, because we auto capture the context of all the information that's going on around these notebooks, we're able to do much deeper introspection about exactly what's going on as you progress through this entire pipeline. So here, I already mentioned that I broke this up into 3 steps. What I'm going to do is I'm going to execute this same thing, except this time I'm going to push all that context information in between those steps to the cloud. And here it's, again, don't look at this specifically. This is not, the website's not the interesting bit here. I'm just pushing it off to this metadata URL and recording everything that's going on in between these steps. And because of that, here I wrote this very, very stupid website that it shows you in between, you have the steps and you have all the inputs and outputs of each of those steps that I declared. Step 0, step 1, and step 2. And I can see every variable that was defined and executed and what the input and output for each of those variables was. And so you see B was undefined before we got to step 0, then it was defined and left step 0 with 15. Here at step 1, 15 became 2510, and so on. Again, the thing that I'm stressing here is that data scientists didn't have to do anything here. All they did was just write their notebooks and add these tags, and we did the rest for them, quote unquote, for free. Does that make sense?
I've got a quick question there.
Hit me.
Do you see that like playing into, like integrating into other tools? Is that kind of the reason for it?
I do get a lot of questions. I'm an enormous fan of weights and biases and MLMD. They're all fantastic for doing recording of your model metrics. It is my opinion that this is a completely separate thing, meaning you're still going to want to use those in line in your notebook to record things like model metrics. This is much lower level, right? The value of B is not something I'm going to want to record for every step of my training pipeline. However, it is something that I'm going to want when I'm trying to figure out why my CI/CD system crapped out, and it turns out like, oh, I was parsing this value wrong. So I consider this to be much more of like using some of the great observability frameworks out there and wiring it up in that way. So the direct answer to your question is yes, absolutely. It will be part of other systems. I just hacked this together myself. My dream is that we push all this using standard observability stuff to the central observability store, whether or not that's from a commercial company like Honeycomb or it's you're just running the thing yourself. But it's a different track.
So basically, it's to give you more insight on your logs.
Exactly. Well, like I said, the reason I did this in the first place was if you look at these notebooks, right, you do see this kind of pattern. I see this kind of pattern all the time where, when you look at it, oh, you know what, at this phase right here, I wanted to know what B's value was. So I literally had a print statement, or what was the value of J and what was the value of K? Don't remember, here, right? So this is something that I use when I'm in line in my Jupyter Notebook debugging. What I was doing here was, just capturing that and printing it out for people in the cloud. Here's, the value of J and the value of K. Here's the value of B as it progressed. And the funny part about this is it does this independent of print statements. I just capture it and show it to everyone who wants to see.
And so that was just by using the tag on there, and then you had those print statements, and so it was coming up on here?
No, actually, it's actually even cooler than that. So Python offers a lot of richness here. I do want to support other languages, by the way, but I've started with Python. Python offers a lot of richness here because there are local and global dictionaries for all that variables of all values. So all I do is I grab that and serialize that into a way that allows you to see what's going on. So for each step, as you enter, I push off the context. And then as I exit, I push off the context. And the diff between those two tells me what went on inside that. So I don't care if you never wrote a print statement, I'm going to be able to spit this stuff out.
Oh, nice. Okay, cool. All right.
Cool.
Yeah.
Okay, so that's the demo. We do currently, we just actually had a very smart guy, Luke Marsden, do some work on supporting MLflow and weights and biases, and exploring TensorBoard for doing some automated auto logging, which I think is really cool. We had a group out of the UK, Phil Winder of Winder Research, use this to build 5 different models, and just to explore to see, make sure we're doing it right. Oh, sorry, I just restarted the video. Since this video, even we now support base images for each container, for each step. So you can say, hey, I want this step to execute under Python 3.7. I want this step to execute using a Python or a private image with this particular context. And like I said, we don't just support Kubeflow, we also support Azure Machine Learning. And again, that's only because those are the 2 that I had easiest access to. I would love to support many, many different platforms over time.
And how can we get involved, I guess, is the main thing that's probably going through some people's mind right now.
Yes. So here are some of the near-term problems I want to address directly when it comes to how we go forward. So you can see them here: environment execution, output logging, like where you log. Do you log to printf or do you log to some central place? Support mocking, particularly external systems mocking, to make that much easier. Making sure, you're going to see this repetition a lot, making sure it's trivial to change values by the environment you're running in. So if I'm running locally, use a CSV. If I'm running in the cloud, use this MySQL endpoint. Those kind of things, we see that happening all the time. Making it easier to do parameterization. I really want to reuse stuff like Papermill in order to do that. Downloading external files, blah, 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 blah. You can see all these kind of things here that we're going to go through. And whether or not that's doing it via an IDE or a kernel extension or SDK or service, I want to do all of these things. This is absolutely designed to be open source and non-commercial, but support commercial entities, and we're just figuring it out. But at the end of the day, the goal is what you see here, right? A user experience that is much closer to the way that I think data scientists want to run, and much more built to share and open, right? So like, imagine being able to say, hey, that repo over there, I want to reproduce it. Just run it again, even with sample data. Imagine me being able to go to a command line and say, same program run, and point at a repo. I think that would be transformative. And we're not there yet. Or imagine saying, hey, you know what, I'm done. I now want to serialize everything I did into a flat format and export it, do that as well. Some of the ideas we have around, what a manifest might look like as it gets bigger. Who knows if this is right? Naming data sets, naming, maybe I'm using Kubeflow and we name the services that are required. Maybe we name specific disks that you need to mount or, make available. Again, this is just mental exercise, and we're just kind of exploring. But at the end of the day, exactly to your point, we're still too early for people to do code contributions just yet. You can absolutely reach out to me privately. Here you can see we have a mailing list. We have a project, Slack, which you're more than welcome to jump into and ask me directly. That's where I publish new releases and things like that. You can actually go out and download the thing right now. The binary's out there, it's installable, all that good stuff. But more than anything, it is, if you are facing these problems where notebook developers want to move to cloud in any form of scalable situation. You have 5 of them working together and are running into this problem, please come talk to me. I would love to explore your problem to see if we're addressing your needs in this and make more changes. And I have the repo up there. The repo, the CLI is not accurate, unfortunately. We're hoping to release it soon. But the rest of the repo, there's lots of stuff there. I mentioned those models and things like that, all of which work. And so you can download and mess around with those as well. Cool.
This is awesome. And it's a problem that obviously very well about, and it comes up so much in the community, right? Like that's such a common theme is how do we productionize notebooks? Should we even be productionizing notebooks? What are we going to do about these damn notebooks? So I guess the main question that I have here is, are you enabling bad coding practices like by doing this? Are you just saying, all right, data scientists, we don't expect you to figure out this whole like best practices, or I know you don't like to use the word best practices, or the tried and true ways that things work.
So it has been my experience that data scientists, it's not like data scientists want to write bad practices, right? I'm serious, right? The problem is that we in the software industry have given them on the order of 0 tools to write good practices. So for example, last night I was just going through a public notebook to see if it would work using SAME. And they had, I am not exaggerating, over 100 lines of code just to download content from an external service endpoint, right?
Wow.
It was decoding it because it was in UTF-8 format and they needed it in ASCII. It was retrying if the thing wasn't available. It was doing loops and things like that. There was no form of callback, no event-driven stuff. And so they just hacked it together because they needed that step. I would never ask them to like become experts in asynchronous programming. Just like if you're writing Kubernetes, I wouldn't ask you that either, right? The beauty of something like Kubernetes was that it provided this abstraction layer over the top of very complicated concepts, which is exactly working as intended, right? Like you want abstractions, smart abstractions. And so my goal is, yes, I want to help them write better code. I want to do that by giving them tools to eliminate as much boilerplate as they possibly can, and enabling consumption of a lot of really complicated frameworks out there. So, for example, Dask, who like I'm just in awe of. Again, I hope I'm not insulting anyone, but God help you if you have to go and learn, asynchronous distributed futures, from their documentation, because you are going to tear your hair out trying to figure this out on your own. It's really hard. But at the end of the day, if I'm a data scientist, I'm just like, well, I have this data frame that's 100 gigabytes. Can't I just execute it across 10 nodes? Just do it. Here's the function. Go do it. Like, that's pretty straightforward and pretty boilerplate. Like, could we wrap that in a way that makes sense such that on my local machine, it picks up 10 threads, but on the cloud, it executes against 10 nodes? Absolutely. That's super trivial for us to do. Now, I want to be really clear. Like, between, now and day one, when we actually launch this thing, I expect to address no more than, 25% of total notebooks out there in the world. I'm sure there are going to be huge gaps in the thing that we do. But if we just make those 25% of people's lives easier, they will be very happy. My optimistic, like fever dream goal is to hit no more than about 75% of total workloads. I'll be honest with you. Is it likely that this is going to be the way that people roll out the next BERT, the next GPT, the next whatever? Probably not. It's just that's too much hand coding, too much thinking and things like that. On the other hand, those people who are building in those 75%, holy crap, they are doing way too much, repetition, re-implementing, all that mess. And, our goal is like, give those people a path to glory. And maybe I'm pessimistic. Maybe over time we can get up to, I don't know, 90%. We will never hit 100%, but we can certainly do a lot more and help those people write better code. But don't ask them to completely change their focus and go have to get a PhD in distributed computing.
Yeah. Yeah, I see the point exactly on that. So what are, because I know that you're looking at, as you said, optimistically 25%. Are there certain use cases or notebooks that you feel will fit better into this?
Yeah,
as
so I
opposed
mean, interestingly, when you did a analysis of it here, this is again this public GitHub study. It turns out that, and this is why I said that 75% number, about 75% of those 6 million notebooks are direct hits. And by that, what I mean is you use no control flow and your entire notebook is monolithic as it is today, right? Meaning no control flow means no call out, if statements, for loops, anything like that. Most notebooks are pretty straightforward things. My take is if you have a notebook today that does need to move off a laptop, and I hope I'm convincing in saying all notebooks need to move off of laptops. This is one area where I will not be moved. Like if any data scientist in your organization is building a model on their local machine and you are betting your business on it, if it is sitting on your laptop, you are not if, but when you will have a nightmare scenario. That person will leave. That person's laptop will die. That you'll run out of training. It won't be trained in 5 years and you don't realize it. You won't have automated tests. You won't have drift analysis. You will, if you're betting your business on it and it's important for you. If it's not, don't worry about it. Really, don't worry about it. But if it does matter to your business or your use case, if you are doing anything on a local machine, bad things will happen. Please figure out a way to do it elsewhere. And I'm not saying it needs to be on a giant Kubernetes cluster or anything like that. Use Git, check it in somewhere, push it to some object automatically using MLOps or GitOps or whatever it is, and then train it there. You will thank me. But so the direct answer to your question is, if you have a notebook that needs to be trained in various environments, and your notebook is fairly straightforward, meaning like the total number of imports of external files is small, this is a direct hit for you, really. We support a lot of things. We already support, again, just in proof of concept. I can't stress on that. Don't bet your business on this yet. But we support various environments. We support caching. We support imports. Like I said, one of the biggest things that people want coming up shortly is data sets by environment and parallelization. And just those, as you can see, the code you saw here was all real and live and running.
Well, I think this is such a good antidote for those people. Just yesterday, I was on a meetup on a panel, and it was with 2 other engineers or MLOps specialists, and they were talking about how they've outlawed notebooks in their organization, and it feels like that, like after hearing what you're talking about, that is such a poor way of going about it, even though we know that, yeah, like you just said, like it's very dangerous to have these notebooks, especially if it's just on a laptop.
Yeah.
But then why make someone learn and use something that they're not really 100% comfortable with, or that they're not enjoying and not able to get like the most juice from? And so this is a great way to change that dynamic and say, it's not that it's either a yes or no, we support notebooks or we don't. It's like, here is the way forward with notebooks.
Yeah. No, I look, I'm with you, and I do get the impulse, right? Today, I think that's actually a very defensible position, because as great as notebooks are, they are very detached from a lot of stuff. You have outputs in there, you have all kinds of artifacts, and the Jupyter community, God bless them, is very adamant about not making changes to a lot of this stuff. So I really do think that it's going to be a set of tools like this that aggressively understand that Jupyter is not changing, that's not in the DNA of their community, but use that as a benefit instead of what it is today, which is something that's holding data science back, I think. And
Exactly.
so, again, I think it'll be tools like this, and maybe it's mine and maybe it's not, right? There's a lot of great things out there. I already mentioned Jupytex, which I use, NB Convert, which does stuff. Fast AI is doing some amazing stuff around NB Dev Live. All of those are good, but they're really just scratching like this much of the surface.
Yeah, that's it's incredible to see, and it's exciting because people are waking up to the fact that there is that pain point there and something needs to happen. And so it's very cool that you're doing this and you brought it on here to show us. And this is, again, I've told you this when we were on the Feast podcast, but you have become one of my favorite people to talk to because of the vision that you have and how you see things.
Yeah,
just a little bit
I mean,
before the rest of us.
way, way, way too kind. I'm just a guy who talks a lot, really.
Yeah, that's humble, but I appreciate you coming on here again, and hopefully you can come on in a few months or whenever you get this really rolling and you launch and show us what the next or the evolution has been, and then we can tell everyone. And it will be nice when that does happen, because whenever those threads pop up in the community that want to talk about Jupyter Notebooks, we can just say, go to the same project.
Yeah. Well, I mean, again, I can't thank you enough for having me on. The number one way to find out, or by the way, push the system in a direction that's beneficial for everyone is jump in the Slack or just email me. It doesn't have to be public at all. And spend a half hour, download the binary, try it out. When it fails, because I'm sure it'll fail in the first like 3 minutes, tell me why, and I'll fix it for you. And then we'll just iterate from there.
There we go. That's it, everyone. Your perfect call to action. So, David, thanks again, man. This has been awesome as always, and hopefully the intro was not too cringeworthy, and we didn't make everyone cancel.
It was fantastic.
And then some people, on YouTube, they put the comments. There's a guy that will go around and on all the comments, he'll just put where we actually start, like skipping over the intro. And it hurts my ego so bad, but you know what? I got to get over it. He'll just
really? That's brutal.
But yeah, so it's been good fun, man. I appreciate it, and we'll let everybody go. See y'all later. Hopefully you enjoyed it. Reach out to David if you have any more questions, and we'll see you next week.
Thanks, everyone.